So this is the 2016 Leaving Cert Ordinary Level Paper 1 and we're looking at question number 8. Kieran has 21 metres of fencing. He wants to enclose a vegetable garden in a rectangular shape as shown. So here's our rectangular shape. Part A says, by writing an expression for the perimeter of the vegetable garden in terms of x, which is the length in metres, this is x, and y, which is the width in metres, show that y is equal to 10.5 minus x. Okay, so by writing an expression for the perimeter of the vegetable garden. Okay, so the perimeter of the garden is the distance around the whole garden. So from here to here to here to here. And if this is a rectangular shape, which it is, this would be x and this would be y. So the perimeter would be x plus y plus x plus y. And we know that that perimeter would be equal to 21 because he's 21 metres of fencing. So the four sides added together is equal to 21. Okay, so now we can tidy that up. The x and the x gives us 2x. The y and the y gives us 2y. Is equal to 21. So now we can divide across by 2. If we divide everything by 2, that's going to leave us with, these 2's cancel. So that's going to leave me with x plus y is equal to, and 21 divided by 2 in your calculator, that's 10.5. So now, remember we have to show that y is equal to 10.5 minus x. So all we need to do now is bring this x over here, becomes a negative, and we're left with y equals to 10.5 minus x. So we've shown that, what we were asked to show here. Okay. Part B says, complete the table below to show the values of y and a, which is the area of the garden, for each given value of x. Okay, so we're given these values of x across the top from 0 to 10, and we have to complete the table to fill in y and then a. Okay, so, well, we have, from previously, we know that y is equal to 10.5 minus x. Let me just write this up here. Y is equal to 10.5 minus x. The area will be, well, the area of a rectangle is the length by the width, so the area will be x times y. So the area will be x multiplied by y, xy. Okay, so if we have a value of 0 for x and we put that in here, that gives us a y value of 10.5. And if we change the x value to 1, y will be 10.5 minus 1. So just to be clear here, what we're doing here, we're replacing these x values with all these values here in turn. Okay. So yeah, if I replace that x with 1, y is equal to 10.5 minus 1, which is 9.5. The next one, if I replace the x with 2, 10.5 minus 2 is 8.5. 7.5 for the next one. This one's done. 5.5. 4.5. So again, I'm just putting this 7 in here. Y is equal to 10.5 minus 7, which is 3.5. So you've spotted the pattern at this stage. Because these numbers are just going up in 1, we can keep going down in 1 here. And 0.5. Okay, so now we're going to find the area. Now the area is the x value times the y value, so we're just going to multiply 0 by 10.5, that gives 0. 1 by 9.5 is 9.5. 2 by 8.5, you can do these in your calculator, that's 17. 3 by 7.5 is 22.5. This one's done. 4 by 6.5 is 26. 5 by 5.5 is 27.5. 6 times 4.5 is 27. 7 times 3.5 is 24.5. 8 by 2.5, that leaves 20. 9 times 1.5, 13.5. And 10 by 0.5 is 5, 10 halves. Okay, so that's the table filled in. Part 2 says use the values of x and a from the table to plot the graph of a on the grid below. So using the x values from 0 to 10 and then my a values. So 0, 9.5. So I'm going to plot these on the graph here. So I can see this graph here. I've got x values across the bottom and a values going up the side. Okay, so let's see, what have we got? We've got 0, 9.5 and 17 for the first three. So we've got 0, 0, 9.5 then. 9. Halfway between 9 and 12 would be 10.5. Should be there, so 9.5 would be somewhere here. And 17, I think, was the third one. Yeah, 17. So over to 17, so 15. 16 and a half would be there, so 17 would be just above there. Then we have 22.5, 26, and 27.5. So 22.5. Leave these so they're in view. 26. 25.5, 26 will be there. 27.5. And then 27. Then 24.5. 20. Get rid of that one. 20 would be, so 19 and a half would be there, so 20 would be here. 13.5 and then 5. So 13.5 would be exactly here. And finally 5. So there we go. So now we're just going to join this up with a smooth curve. Smooth as a curve as you can. Okay, so there's my curve as smooth as I can. Just see the top goes around like that. Okay. Part C then says, use your graph to estimate the maximum value of A and write the corresponding length and width. Okay, well the maximum value of A would be this point here roughly. So from there, if I go across to there, that'll give me the maximum value, and I'd say that's about 27.5. 27.5 for A, and the height we drop straight down, which is about 27.5, which is about 5.4. 27.5 and 5.4 for x. So about 27.5. And then the x, which is the length as far as I remember. X is the length, yeah. And our x value was, what did we say? .4. So the width then, if we remember, the width is y is equal to 10.5 minus x. So y would be equal to 10.5 minus 5.4. That gives us a value of 5.1. Okay, that's the estimates from my graph. Part D1 says show that the area of the rectangle can be written as A equals 10.5x minus x squared. Okay, well the area of the rectangle is x by y. So that's x times, we expressed y as 10.5 minus x earlier on in the question. So if we multiply them out, x times 10.5 is 10.5x, and x times minus x is minus x squared. So there we have shown that the area of the rectangle can be written as that there. Okay, part 2 says find dA dx. Okay, well, if A is 10.5x minus x squared, dA dx will be what you get when you differentiate that. So if we differentiate 10.5x, that's just 10.5, 10.5. And then differentiate minus 2x squared, you bring the 2 to the front, so it becomes minus 2x and the power reduces by 1, so minus 2x to the power of 1, or just minus 2x. So that's dA dx. Part 3 then says, hence find the value of x which will give the maximum area. Okay, well, the maximum area will come when dA dx, which is the slope of the tangent to the curve at a certain point, but we know that when that's 0 will be the max. Because if you have a curve like this, the tangent will have a slope of 0 at this point here, at the maximum point, or indeed a minimum point. But so we're going to let dA dx equal to 0. So that gives us 10.5 minus 2x equal to 0. So if we bring we're going to solve this down, bring the minus 2x over here, becomes positive 2x. So that gives me 10.5 is equal to 2x. So now I can divide both sides by 2 because I just want to have x. So if I divide both sides by 2, using x on one side, so x, and the other side I'll have 10.5 divided by 2, which is 5.25. So that's the value of x that gives the maximum area. And finally, part 4 says find this maximum area. Okay, well, the area, as we said before, was xy, the length by the width. So we know that the maximum area is when x is 5.25, so I can put in 5.25 for x. And we knew also from before that y is equal to 10.5 minus x. So that means that y is equal to 10.5. At the max, we know the value of x is 5.25, which is 10.5 minus 5.25 is 5.25 again. So that's going to be my y value. So it's going to be 5.25 multiplied by a y value of 5.25. So the y is 5.25 and the x is 5.25. So the maximum area is actually when the shape of the rectangle is actually a square, and a square is a type of rectangle. Okay, so just to finish up, 5.25 by itself, that gives us an area of 27.5625, and the units was meters squared. So don't forget your units. So that's the answer for the maximum area, and that's the end of the question.